Hello, Year 9s. Welcome to Mr. Chan's classrooms. How are you? So today in math, we will actually apply trigonometry into some real life situations. The key words that we are looking at are angle of elevation and angle of depressions. These two keywords are very crucial because it's gonna help us be able to solve a lot of real life application problems. So let's get into it. So what actually are angle of elevation and also the angle of depression? I want you to look on your right hand side. There are two different types of angles. So let's go into angle of elevation first. Angle of elevation, right here, this one, is actually angle that is pointing upwards, which has a upwards angle. So what that means is this is the horizontal, that is the straight line here. So anything that goes up from there are called angle of elevation. So if I have a triangle, alright, and I'm referring to this angle, so that is my reference angle. So since this angle is actually going up, what happened is we call them the angle of elevations. Alright, angle of elevation for this one. Angle of elevations. On the other hand, angle of depressions is actually the angle that has downward sloping line. Okay, so pretty much like going down, which is that one. So but it has to go down from the horizontal line. Okay, so the horizontal is your straight line. So that will be your angle of depressions. Okay, so in this situation, there will be no angle of elevation depression on here, sorry. But if I draw a triangle that has a downward slope like this, and that will be a 90 degree, obviously that's the right angle triangle, and the angle of depression in this right angle triangle will be this one. Okay, will be that one. It's your reference angle, but that reference angle has a name of also called angle of depression. Alright, so once we get to know these two, we can actually jump straight into our questions using both of these angle. And obviously we have to use SOHCAHTOA as well. SOHCAHTOA. Alright, so SOHCAHTOA is gonna be everywhere for your trigonometry. So let's look at example number 1. So example number 1, as you can see, we have a badly drawn helicopter here. And then along with the helicopter, we have a landing pad. Okay, so a helicopter is flying at a constant means maintained at the same altitude of 91 meters. Sight the middle of the landing pad at the angle of depression of 16 degree. How far in meters must the helicopter travel to be directly over the landing spot at an altitude of 91 meters? So the first thing that you're gonna have to look at is who is the main character in these questions, which is the helicopter. Okay, it's not the landing pad, because what happened here, it says a helicopter flying at a constant altitude of 91 meters side the middle of the landing pad at an angle of depression. So it kind of refer to the helicopter is the one that has an angle of depression of 16 degree. So what that means is, first I'm gonna find out that is 91 meters. So do you think that the triangle should be drawn here like this, 91 with that 91 degree, or should it be drawn right here where the altitude is 91 meters, which means it's above the ground? Alright, which one do you reckon is the right one? So first we're gonna know which one has the angle of depression. So that one won't be an angle of depression, it is the angle of elevation. Alright, so the depression can't be that one, and obviously can't be these two because they are the right angle. So it has to be either this one or that one. Okay, since the helicopter is the subject, the main character, and it has the angle of depression, so angle of depression is going down. Alright, so going down, that means this is the angle of depression. Okay, angle of depression, AOD. So from here we know that the helicopter is 91 meters above the ground and it wants to land on the landing pad. Okay, but the question is asking how far it must the helicopter travel before it actually before it can actually land on the landing pad. So that means your helicopter has to travel all the way here, alright, and then stop, kind of like stop in the middle of the air, and then from there it goes down. So we have to find this length. Okay, so we have to find that length. So let me first get rid of that one. Alright, when you get rid of that one, it gives you a clearer view of the right angle triangle. Since it is a right angle triangle and we know one of the angle and also one of the length, which is 91 meters above the ground. Okay, so the angle of depression right here is 16 degree. So we know it has 16 degree. So from there we also know that is the opposite. Alright, so the 91 meters is the opposite, and we are looking to find that one, which you guys will probably know that is your adjacent. Okay, so with opposite and adjacent and a 16 degree angle, we will have to use TOA, which is tangent degree equal to opposite over adjacent. Okay, so from there it becomes relatively straightforward. What happens is you just need to put in tangent, the degree is 16 degree, equal to your opposite, which is 91 meters, over adjacent. We are trying to look for the adjacent. So what happened there is you need to find out what tangent 16 is. So that means you put in your calculator 16 tangents equal to 0.287. Okay, equal to 91 meters over A. So from there, as you know, some of you probably know how to swap this around, which I have taught during lesson. in our class. If you don't know how to do that, please come and see me. I will teach you how it works. So all you need to do is swap these two around, and then you will end up with A, which is your adjacent, equal to 91 meters over 0.287. So from there, 91 degree, we will divide it by 0.287, which will give you the length for the adjacent to be 317.07 meters. Okay, so what that means is the helicopter basically need to travel 317.07 meters, okay, to just above the landing pad before it can land at the landing pad. Okay, so that is the example of using angle of depressions to find out the length of one of the unknown for right angle triangle. So how you finding this? Is this a new thing to you? Because I don't think I've actually touched this before. I have actually mentioned the angle of elevation and depression before, but this is the first time I actually properly introduced to. So good work for listening, and we will actually do another video about angle of elevation, because the real life example, because this video is a bit longer than I expected. So see you in the next videos. Bye.